All right, in the previous lessons, we learned how to find the area of a square given the side length and how to find the length of a square given the area. Thanks for setting over there. In this section, we will study how to find the volume of a cube given its side length and how to find the side length of a cube given its volume. So I should be able to go forwards and backwards on this. Find the volume of the cube to the left, describe the methods you are using. Okay. Now the interesting thing about this cube is we can't see all the parts of the cube. So drawing this may be helpful. So this would be 1 cubic unit radican. This corner cube radican. Well, we can see just from the top there that corner cube. Alright, so yeah, there we go. So this cube radican also has a cubic unit. So right there we've identified 2 cubic units, but then we've got this one as well. Well, we've also got these other ones, and this would make up a layer of cubic units, and specifically we should be able to see that there are 9 of them. 1, 2, 3, 4, 5, 6, 7, 8, 9 of these cubic units. And this is for 1 layer, as we can see up in count.
Oh, so there's 18. Why not 27? Sorry.
So yeah, if we look at that, that's 1 layer, but then we've got this other layer right here. And this part is part of the same cubic unit. So yeah, this would be another layer, so that's 9, 18. And then we've also got this last layer right here at the bottom, which would give us 27 cubic units. So we know the volume of this, V for volume, is 27 cubic units. But in addition to this, we should identify, because with volume we're looking at length times width times the height. Well, since this is a cube, all of these are the same, so it really becomes the side length to the power of 3. Now the nice thing about this is if we make it equal to V, it doesn't spell any bad words like area did. But we can identify this. The length is 3, the width is 3, and the height is 3. So each of these side lengths is 3. And then in the calculator we could put this 3 times 3 times 3, which is 27 cubic units. Now this is the nice thing about I guess you could call it a rectangular prism, a cube specifically though, but rectangular prisms in general, if you find the volume of 1 layer, you just multiply it by its height to find the actual volume of the whole thing. The cube above is called a perfect cube because all the side lengths are the same. A cube is considered a perfect cube if you can arrange smaller unit cubes to build a larger cube. In the example above, 27 units cubed were arranged to build the larger cube shown. Can you build additional perfect cubes to fill in the table below? The first one has been done for you with the cube shown above. Alright, so let's say that the dimensions were 1 by 1 by 1. So 1 times 1 times 1. Then the volume of the cube would be 1 cubed, which would give us a volume of 1 cubic unit. And the side lengths, as we can see over here, the ones are ones.
Like 2 of these.
Alright, so the next one we can do, let's say that the side lengths were 2, so 2 by 2 by 2. Then the volume would be 2 cubed, and then would have 2 times 2 times 2, which is 8, so 8 cubic units. And we already saw the side length was 2. Well, continuing this, we already did 3, so we'll do 4s next. 4 times 4 times 4, which is 4 cubed, which would be 64 cubic units, with the side length of 4.
You could do 5 also.
So yeah, let's look at fiber up in count. So the dimensions would be 5 by 5 by 5 cubed, which would be 5 cubed. So that's 125 cubic units. And the side length is 5. Alright, so those are the volumes with the side lengths. These first 8 would be pretty good to remember if we could, but we just don't deal with them often enough to really memorize them. which is where calculators come in. In the previous sections, we learned the following. If we're given the side length of a square, we can just square that, and then we'd have the area of a square. But if we had the area of a square, and we wanted the side length, we would square root that garbage. So this time, though, we're dealing with volume, which means we have the side length cubed. And just a little bit about those cubes up in here. So unit cubes indicate that we're dealing with volume because volume is three-dimensional. And this shows that the units are three-dimensional as well. At the bottom here we wrote cubic units, or CU, cubic units, instead of units cubed. But it is the same thing. It doesn't matter which one you use.
You played math.
So in this section we see that if we are given a side length of a cube S, then its volume is S cubed, which is shown in the second column right here.
That's naughty.
If we're given the volume of a cube, like the third column, then the side length is what we would call the cubed root of the volume. So explain in your own words what cube root of b means. That means that some number multiplied by itself 3 times is the volume. And we can see right here, the cube root symbol is shown with the v there. Cube root. So the only difference between these, right? Square root didn't have any number. Didn't have a number right there. Cube roots do. They have the 3, which shows that it's a three-dimensional cube.
I think I can do that on my calculator.
Your sides.
All right, so on this one, we need to find the side length of this cube.
She's gonna win the Super Bowl.
All right, so the volume is 27 inches cubed. So if the volume is 27,
Hey, I don't
then
think
the
your
side
math's
length,
working too well.
the side length, if we look back, the volume is the side length cubed. So side length is the cube root of the volume.
Thunder.
So on this one, we're just going to take the cube root of the 27, which we should have known from the previous one is 3, but we do need to label this in the inches. Now, if we wanted to put this in the calculator, there's a couple ways we can do that. For the ones that we have here in class, you're going to push. All right, let me double check. All right, so for the calculators we have in class, the first thing we need to do is tell it that it is the cube root. So we're going to push the 3 button right here to tell the calculator that it is the third root. Then, to get the cube root on that, we're going to have to push the second button to get to the root. And then we're going to push this button. It's a caret symbol for powers. And you can see right above it, it shows the xth root. So that will give us the root, and for us, that would be of 27. So 27, and then push equals, and then it will give you 3. All right. All right, number 4, we want this is the volume. The volume is 125 cubic meters. So to find the side length, right, the side length is the cube root of the volume. So we'll just cube root the volume, which is 125, and this will give us the side length, which is 5 meters. Now notice these are all perfect squares. We'll get to the point where we're using not perfect, I said perfect squares, perfect cubes. These are all perfect cubes, but eventually they will not be, just not right now. All right, for this one, since we already know that the side length is the cube root of the volume, and the volume on this is 30 cubic centimeters, so I'm just going to replace the volume with 30. Now if you put this in the calculator, you're going to get a decimal value, which we don't want right now. So right now this will do, we just need to label it centimeters. Now eventually we'll get to the point where we can simplify these. Cube root of 30 can't be simplified either, so that's okay. So 6, find the side length of this cube given that volume. So again, the side length is the cube root of the volume. And we can see the volume down here. is 100 cubic feet. So I'm going to replace that volume with 100.
Wait, what about 5?
Now 100, there's no number multiplied by itself 3 times. That's a whole number. That's 100. So again, we're just going to keep it.
You
As
said you were
feet.
doing number 5.
We did number 5.
Oh, what was the sideline?
Number, it
7 and 8, let's fill in the blanks. So 7, the cube root of 27 is 3, because 3 cubed is 27. Same with 64. That would be 4, because 4 times 4 times 4 is 64. So number 9, the cube root of 1 is 1, because 1 cubed is 1. Continuing, number 10. Alright, so the cube root of 125 would be 5. Again, that's because 5 times 5 times 5
Right there.
is 125.
Wait, did you say?
Yeah, we've done that one already. Let's look at 11 then. The cube root of 343 is 7. Because 7 times 7 times 7 is 343.
Wait, how do you like erase
So it would be 7.
yourself? How do you like?
Alright. So on this one, fractions for roots, these work the same way as the square roots did. So as it turns out, we got the cube root of 1 divided by the cube root of 216. And the cube root of 1 is 1. And the cube root of 216 is 6, right?
Yup.
So that would be our answer right there.
Yay!
Alright, 13 will work the same way. Here we've got the cube root of 1
Oh, I got it.
divided by the cube root of 1000.
Dang it, you.
And yeah, that's very good. The answer is 1/10.
Hey, the next one's 2/5.
Whack out.
Yeah, the one after that.
Alright, so 14. I'm going to break this up though. This would be the same as the cube root of 8 divided by the cube root of 125,
Which is 5. We already knew that.
which is 2
We're 5.
fifths. There's our answer.
Playing Fortnite tonight?
Let's look at this one. I'm going to treat this one the same way that we did the square root. So as it turns out, I'm going to take the cube root of the fraction on this.
19 in disguise.
So this is 1, and that's the thousands position. Tens, hundreds, thousandths.
I just put it in the calculator.
Well, it seems like we just did one exactly like this. So I got the cube root of 1, cube root of 1000. So the final answer ends up being 1/10.
Really?
Oh,
Which is
but I
that's
have
the same thing as 0.
Alright, good luck.
Pull my math teacher. Okay, so if I calculate this, gives me the answer of 0.3. So,
Why'd you round up?
You're
what?
rounding. Did you forget?
Wait, hold on.
Your
calculator can't always be trusted, you know. Yes, it can. It is 0.3.
checking his work.
It is 0.3.
Mr. Cello.
I call him bull. I got.
Yes, I'm
I got way
finished.
different answers.
Very good.
That is.
Yeah.
So yeah, we can use a calculator to do this, but on a test you got to show some work. So again, I would change this into a fraction. That'd be 27 thousandths. And if we take the cube root of both of these, cube root of 27 is 3, cube root of 1000 is 10, and that's just the decimal form of this fraction.
Oh, that's how you would show your.
Wait, so we do round.
Alright, the cube root of 32. Alright, as it turns out, these ones are going to simplify exactly the same way as the square roots did, but instead of looking for pairs, we're looking for triples of those numbers. Alright, so on this one, we're going to break this up and see if we can find any triples from this. So 32 would be something like 8 and 4. And that would split up into 2 and 2. There's primes. And then 8 would be 2 and 4. So 4 would be 2 and 2.
Oh, whoa.
So as it turns out, this is just the cube root of 5 2s. 1, 2, 3, 4, 5. And again, we're looking for triples now instead of pairs. So right account, I've got this triple 2, which means it's going to come outside of the cube root.
Oh, yeah, now we're looking for triple.
Now I don't have any other triples, so I do the 2 times 2, which is 4.
I understand.
Now it's important to be able to distinguish between the two. Cube roots, we need triples. Square roots, where it doesn't show that a number where that 3 is.
We just need doubles.
Then we just need pairs, or yeah, doubles should be fine. All right, here we go on this one. I should do this one because we haven't. All right, so we're gonna break this up. So since 135 ends in a 5, we know it's at least divisible by 5,
And 27.
and then you get 27.
That's why I did 2.
Well, 27 breaks up into 3 and 9er,
I just did 5 divided by 6.
and then we got the 3's, these 3's as well.
Without breaking 3 things.
So this ends up being the cube root of 3 times 3 times 3 times 5.
Oh, I'm
Now we've got this triple radical, which makes that a perfect cube. So that's 3. And then the 5 doesn't have any triples to go with, so it's just the cube root of 5.
Yes! I got it right.
I am sushi.